Hello, I'm Jim White, and this is Chapter 1 from Complete Requirements via Use Case. In this chapter, we want to talk about system requirements. Exactly what is a system requirement? Simply put, a requirement is some sort of condition or capability that we want the system to adhere to. As we'll learn, there are different types of requirements. But our focus is going to be on those types of requirements that focus in on user goals. In other words, we want to build our requirements that capture what a user wants to accomplish, their goal. We'll look at that from the perspective of a user in a particular role. When we think about a role, the hat that a user wears. You and I wear many hats. We are sons, fathers, daughters, mothers. We might also be an employee for an organization. We may be a coach or a mentor. We wear many different hats, therefore serving in many different roles. Users with regard to a system may also have many different roles. So we're going to want to study the requirements from the perspective of a user in a role, getting to know and understand their goals, therefore their requirements. And when we talk about that, we're going to learn that a requirement should contain information about the goal from a business perspective, an understanding of the events in action in the business that are going to occur to accomplish some sort of goal with the system. So it's what the user wants accomplished, when they want it to accomplish. It might also include things like business rules for controlling those events in action, and exception or issue handling processes, sequence of events for dealing with those problems that occur in any kind of business situation. What requirements should not contain, however, are any kind of implementation details. We're not concerned, in other words, with the how any system should respond in satisfying user needs, how a user pushes a key to get some action or event done, how they bring up a screen, how they integrate with some sort of device to get their work done. Those are not the focus of what we want to look at with regard to requirements. So we're really focusing in on the quarter-inch hole versus a drill. In other words, we're focusing in on what a user wants. When we're looking at building a building, for example, a user may need to have a lot of quarter-inch holes drilled. The tool, the system, in other words, that provides that quarter-inch hole, the drill, is not the focus of our requirements gathering process. We may have lots of details about that drill that we're going to learn about, maybe in terms of some of the way it operates. But at the beginning, when we're really trying to understand the business and capture the requirements of the system, we want to know more about that quarter-inch hole, not the drill. So as I mentioned, two different types of system requirements. There is the what, the functional, otherwise known as user or business requirements, what the user wants to accomplish, versus how, which are usually labeled as non-functional or technical requirements. Now, non-functional or technical requirements are still important. They just happen to function on a different part of the system, and usually are developed and understood a little bit later in the development of a system. So functional requirements, in other words, what the system will do in an effort to complete a user's goal, reflect the business. In order to read functional requirements, you have to be able to read and understand the language of the business. Functional requirements are the focus of use cases and the use case model. And of course, they're obviously too the focus of this class. Non-functional requirements, again, all around or centered around the how the system will behave. In order to read and understand non-functional requirements, you have to be able to speak in terms of technology, at least typically. So we have to be able to understand automation and the technology of our software systems. Non-functional requirements help to drive out the design of our system, the architecture of our system. And they're often concerned with what I call the ABUL characteristics: usability, reliability, supportability, maybe scalability, things like performance and security. And in fact, we usually find that non-functional requirements are not, as I mentioned earlier, known early on in the phase of a project, as we're trying to get our arms around what the users are trying to accomplish. Non-functional requirements tend to work their way out as we talk to more and more of both the user as well as the technical community. Now, non-functional requirements, while we'll mention them a little bit during our class, are not the focus of this use case class. Everybody believes in the importance of requirements, and probably no more, or I should say, and probably in nowhere has there been such a succinct study about the importance of requirements than that which is listed in what's called the Chaos Report. This is a report done by the Standish Group that started in 1995. It comes out every few years, and it gives us a lot of the reasons for both success as well as failure of a lot of our IT projects. And starting in 1995, the Standish Group highlighted the fact that the three major reasons that a project will succeed are user involvement, executive management support, and a clear statement of requirements. So as we can see right away, requirements, very important. One of the key success, if not one of the top three key success factors on the success of an IT project. And one might even be able to stretch this a little bit and say, well, both user involvement as well as executive management support is probably dictated largely on how well they're able to read and understand requirements at an early phase in order to be able to get involved and to be able to show their support for a particular project. On kind of the opposite end of the same spectrum, when we look at failures in IT project, the same chaos report the Standish Group provides, it gives us an indication that requirements, or maybe I should say poor requirements, that being incomplete or changing requirements, are typically the two leading factors that led to the failure of our IT projects. And failure is defined by the Standish Group as projects that fail to arrive on time with the functionality required and on budget. Again, when we look at some of the other things around failure or challenged projects, as the Standish Group likes to say, we will find that things like user input, again, is one of those leading contributors. And there again, we might actually be able to say that lack of user input may, in some circumstances, and probably is in a lot of circumstances, due to either poorly written or incomplete requirements themselves. In other words, a user not having a document to which they understand and can fully appreciate in order to be able to provide their feedback. Now, if you're thinking, well, these reports are quite dated, Jim, they're from 1995. In fact, the Standish Group has regularly reported on the status of our industry through their Chaos Report. And as you can see through the numbers here, even as late as 2010, while the failure rates in some cases have improved, we still see that we have a number of challenged projects out there. And our success rate, while again also improving, probably isn't where any of us would like to see it. So we need to improve. Other such reports, one here from the JAMA Software Group in 2011, tell us that some of the same problems reside with requirements. Two of the key leading reasons, again, poorly understood requirements and poor requirements management. So why are we having so many troubles in the IT world and so many troubles in our IT projects typically related to those requirements processes? Well, when we talk about conventional requirements, that is, requirements you and I might see in our organizations today, we often find that conventional requirements documents often combine what we call a functional and a non-functional. Again, the what and the how of a system, all in the same document or requirements model. We call this design intrusion. In other words, the model, the requirements document often contain both technical as well as business requirement information. We can look at some other examples and see, again, more of the technology or implementation bleed into what probably should have been just plain and simple functional requirements. Because when we combine both the conventional requirement, I should say, when we combine both the functional and the non-functional requirements, what we see as conventional requirements today, nobody understands these documents. The business can't read them because there's too much technology, and developers have a hard time pulling out just what exactly is the goal that we're trying to accomplish with the system. So multiple audiences through one single document often leads to ambiguities and confusion on everybody's part. Typically, we find that conventional documents, again, containing both non-functional and functional, contain too much or too little of the requirements of the system. We have inaccuracies, we have redundancies, and ultimately what happens is these requirements get used by nobody. They become shelfware. They're not used by the business community to understand what it is exactly that the system is supposed to provide. They're not used by the development community to derive implementation and give them a clear picture of the goals that the users are trying to accomplish. And even from a technical standpoint, so many of the technical details are buried in and amongst the business requirements. It's tough to have to actually ferret all those out and make sure that they're actually built into the system. Ultimately, too, these conventional requirements usually don't help managers at all. In other words, they don't provide some sort of means for helping to plan and monitor a project and the system's development. The conventional requirements is a jumble of what the system shall do, not an effective means for planning iterations and making sure those iterations are on time and on budget.